So now for example number 4, it says a car is moving with an initial velocity of 5 miles per hour and accelerates at a rate of 2.4 t miles per second for 8 seconds. Okay, so let's write down what we have. Our initial velocity, V naught, is equal to 5 miles per 1 hour. Okay. The acceleration is a function of time, and it is 2.4 t miles per hour. And it accelerates for 8 seconds. And so your textbook asks you how fast, it's got 2 questions. A, what's the velocity at the 8 seconds, after 8 seconds? And then part B, it wants to know how far did the car travel in 8 seconds. Okay, so we got 2 questions there. So I'm going to jot a bunch of stuff down. We got to think about this. The only thing I have is acceleration as a function of time, right? We know that that is 2.4 t. The question they're asking us is what? The first one is how fast is it going? So if my acceleration is a function of time, what do we know about velocity? It's also a function of time. But what do we remember about this relationship between velocity and acceleration? Yeah, so the acceleration is the derivative of velocity, right? Because it's the rate of change, right? My definition of acceleration is the change in velocity. And so in calculus, it's the derivative of velocity, or velocity as a function of time is the antiderivative. So what is the antiderivative of this? Well, we can kind of do it in our head. It's 2.4 t squared divided by 2 plus c. Okay? We'll get back to that in a second. But essentially, the question that they're asking us is, what is this after 8 seconds? So now how do I set that up using calculus? Well, when I do this, which means I would do this. And if I crank through the math, I get 1.2 t evaluated from 0 to 8, right? Oh, it's t squared, right? Now what I did is I just took this, what's 2.4 divided by 2? It's 1.2, right? You can double check your math too. If I take the derivative of 1.2 t squared, what do I get? 2.4 t, right? So that works. So now to evaluate this bad boy at this, I'm going to say 1.2 times 8 squared, that's my first part, the upper limit, minus 1.2, 0 squared. Well, this whole thing's 0, isn't it? So I've got 1.2 times 64. Plug it into my handy dandy calculator. Whoops, got to clear off all my ink here. And so I'm going to say 1.2 times 64, 76.8, right? Does that look good? So this is 76.8 miles per hour. That's per A. Does that make sense? Pay attention to this, because this is just like a type of problem that you'll get on the AP Calculus exam. Very practical. Just about every one of the constructed responses are very similar to this. Okay? Now part B wanted to know what? How much distance did it travel in that time? Well, how can we do that? Well, we know that, just to kind of recap, we said that our acceleration of time is equal to 2.4 t. We said that our velocity with respect to time, or as a function of time, is 1.2 t squared plus c. And when we talk about distance, what do we really want? Yeah, we want the antiderivative of velocity. What's the problem though? There's a c. So I need to solve for c. So I've got v of t is equal to 1.2 t squared plus c. Hey, wait a second. Whenever they give us an initial condition, there's a reason for it. What was the initial condition they gave us? You know what that says? That says that when t is equal to 0, v of t was equal to 5. Did you guys figure all that out? All right. So now we're going to plug that in, and we're going to say 5 is equal to 1.2 t, but t was 0, squared plus c. This whole thing goes to 0, so c is equal to 5. So now what I'm going to do is I'm going to come up here, and now I know for sure that that's my function. My velocity in this particular case, as a function of time, is 1.2 times t squared plus 5. Okay? Well, what was the question for part B?
Distance.
Yeah, I wanted to know the distance that was traveled. Hey, didn't we just do an example like that? We said that if we go from 0 to 8 of the absolute value of v of t, then we would get the distance traveled, right? So this is the way that we find the total distance traveled. Okay? Can we do that? Yep, we're going to do it a little different on the calculator this time though. Ready? What I'm going to do this time is I'm going to go to math, and I'm just going to use the function integral thing. I alternate because I want you guys to see what it looks like graphically, and then I want you to see what it looks like when we, sometimes you don't want to see the graph. Okay? So we're going to choose option number 9. First thing I do is I plug in my function, 1.2 times, and I'm just going to use x. I could use t though. X squared plus 5, comma. What are we integrating over? X. What's my lower limit?
0.
What's my upper limit? Do I need anything else? Nope. So I get 244.8. What is that?
The answer.
The distance traveled.
No, my question, 244.8 is a number, but what does that number represent?
Miles.
Miles. Right? Because we calculated miles per hour, right? But we've got to remember that it's miles per hour. Okay. But we have a second in there because this is like 0 to 8 seconds. So we're timesing this by seconds. So this is where it gets a little tricky. So it's 248 miles times second divided by per hour. So how do I fix that? Now, where this comes from is that the acceleration, we've got to do a conversion. And I want you to think about that. If the original velocity was 5 miles per hour, and my velocity as a function of time is that, and I'm only traveling for 8 seconds, that means that my final velocity would be kind of high. But 244.8 miles is a little. It's kind of a weird answer. That's a lot of miles traveled in 8 seconds. Okay, so your common sense check would probably tell you that might not be right if you stop to think about it. Okay. So we've done all the math right, and that's the math. But because we're evaluating from 0 seconds and 8 seconds, when we plug that into our antiderivative and we evaluate it, we're going to get miles per hour because that's what this function is, and then we have the seconds. So we have to do a conversion factor. 244.8 miles, right, per 1 hour times seconds. And so we can do it per second or we could do it per hour, but basically I've got to cancel out this seconds thing. So one way to do that, if I have 1 second here over 1, I can multiply that by how many seconds are in an hour? 60 times 60, right? Remember that from physics? 3,600 seconds, and that's equal to 1 hour. Now, we all correctly guessed that the unit of measure should be miles. We just weren't quite there yet. Notice now what cancels.
Seconds and hours.
Hours cancel, seconds cancel, and what am I left with?
244.
Yeah, all this stuff. But I'm talking about units. I get miles. So to find the final answer, I'm going to say 244.8 miles divided by 3,600. Oops. Okay. And then that equals, what was it, 0.068?
Yeah.
0.068 miles. Now that's a much more believable answer. Still pretty fast though, a half a mile in 8 seconds. Cruising right along.
That's not
That's like that's not point.
That's not
It's not half a mile.
Yeah.
Oh no. In my mind I was thinking 0.68. I'm tired, man. Okay, any questions? Well then that's not moving very far at all, right? 6/10. Oh, it's not 6/10. It's almost 1/10. I'm going to stop talking. That's the right answer.
Okay.
Okay?
Okay.
In 8 seconds.
No.
Oh, that moved that fast in 8 seconds. Or that